Alright guys, so here's a video on multiplying and dividing fractions. Our goal today is I can multiply and divide fractions and some whole numbers as well. Just like when we multiply and add integers, there's some big differences between them when it comes to fractions. And there's two major differences that we're going to talk about before we get into some examples. The first one is you actually multiply the numerator and the denominator. So unlike yesterday, when we just added the tops, today we're going to be multiplying the tops and the bottoms together. And then the other big difference is you do not need to get a common denominator. And that's super big. Honestly, I think that makes this one a little bit easier. A lot of other people do as well. So we don't need to get a common denominator anymore. That's super nice. So the rules that we talked about a couple days ago when we were just multiplying and adding integers apply. When the signs on the numbers are the same, so like if you're multiplying two positives together, or if you're multiplying two negatives together, your product is positive. You get a positive number. But when the signs are different, if you have one positive and one negative, your answer is obviously negative. All right? So let's take a look at a couple examples so we can work on this. And so example one. So right away, I see that I have one positive number and one negative number. So I'm just going to say that my answer is negative something. And just like I said up there, we multiply the tops together and then the bottoms together. 3 times 4 is 12. 5 times 7 is 35. And that's it. So that's really all that today is going to be. I'm obviously going to give you some harder ones, some ones we're going to have to reduce, some bigger numbers, and things like that. So let's take a look at example 2. That's one that's a little bit tougher, but it's going to really be those same rules that we just did on example 1. Look at your signs, see if they're the same. They obviously are, so our answer is going to be positive. And this one's a little bit tougher because, I think all of us could do 10 times 6, but I don't think any of us could do 48 times 25 off the top of our heads. So we're going to do this thing, and I hope that she talked about it last year. I'm pretty sure that she did. It's called pre-reducing, which means if you look at a diagonal, like let's take a look at 10 and 25, you can divide them both by the same number, as long as you do it to both. So what can you divide 10 and 25 both by? Obviously 5, and you end up getting 2 and 5. So a little bit easier, 48 times 5. Can I do the same exact thing on the other diagonal? Well, yeah. You could actually do it by a couple things. You could do it by 2 and just have both of them. I'm going to just do it right by 6, though, because I'm pretty good at numbers like that. So I can divide 6 by 6 to get 1 and 48 by 6 to get 8. So now on top, all I have is 2 times 1, which is 2, and 8 times 5, which is 40, which can still be reduced a little bit. You can have both of those to get 1 over 20. All right? So let's take a look at the next page. I think I talk about that pre-reducing thing one more time to help you guys out with large numbers. You can reduce. To do this, find a number that divides into the top and bottom numbers on the diagonals together. All right, so what I want you guys to do now is I want you to try 2 different examples to test yourself. Pause the video so you can do it by yourself without me walking you through it. And then when you're pretty confident that you're done, unpause and check. All right, so number 1, our answer should have been negative. And there's a couple different ways you could do it. You could just multiply straight across to get 4 and then 88 and then reduce it that way. I'm cool if you do that. I just like smaller numbers. So I'm going to pre-reduce and divide both of those numbers by, what do you think? 4. You could have done it by 2 as well, but I'm going to do it by 4 to get 1 and 2. And then 1 times 1 is 1. 2 times 11 is 22. Both ways would have worked. Obviously, it just depends on where you'd like to reduce. All right, how about number 2? Looking at it, I see that it's positive right away. I can do the 7 and the 21, right? 1 and 3. Can I do the same exact thing with the 3 and the 39? I think so. 1 and, anyone know? 13. So you have 1 times 3, which is 3. 1 times 13, which is 13. Okay? So it's pretty easy to multiply mixed numbers as well. You just need to turn the mixed numbers into improper fractions first. And we had some practice doing that yesterday. You can't leave them as like mixed numbers like this and multiply the 2 and the 3. It doesn't really work like that. So let's just do what we did yesterday. Let's do 2 times 2, which is 4, plus 1, which is 5 over 2, times, well, this other one's over 3. What's on top? Well, 3 times 3 is 9, plus 1 more is 10. Can you pre-reduce at all here? I don't think so. 5 and 3. Actually, no, you can with the 2 and the 10, right? Divide them both by 2 to get 1 and 5. So on top, you end up having 5 times 5 is 25 over 3. I'll only do it once, this notes, just because usually at this level of math, we don't turn them back into mixed numbers, but they might want you to on the iReady test or something like that. So how many times does 3 go into 25 without going over? 8 times, that's 24. So 1 more gets us 25. All right? So that's one more way that they can make it tougher. Another thing they could do is throw something like this at you. How is this different? Well, obviously, it's a mixed number times a whole number. And that's not that bad. It's actually really, really easy. Any regular number can be rewritten as a fraction with the denominator of 1. So this is really just negative 7 over 1. That's a really easy fraction. So let's rewrite that first mixed number as an improper fraction. That's 2 times 2 is 4, and 1 more is 5 over 2, times negative 7 over 1. So my answer is going to be negative, because I can't make a smiley face with that. And 5 times 7 is 35. 2 times 1 is 2. And there's that. I'm not going to turn it back into a mixed number. I did it once for you guys. That should be enough. All right. So on the next page, I have you guys trying 2. Again, just like before, pause it, try it, and then unpause it to test yourself. All right. Hopefully that was enough time. Let's take a look at this. I'm going to pre-reduce it the 9 and the 15 and make that a, well, what can I divide 9 and 15 both by? 3. So 3 and 5. So it's going to be negative 4 times 3 is 12. 5 times 1 is 5. So negative 12 over 5. Obviously, it could also be, what is it, negative 2 and 2/5. Let's take a look at number 4. I'm going to turn them both into improper fractions. And how about the smiley face on this one? I got a nice smiley face there. So this one's going to be positive something. 3 times 3 is 9. 1 more is 10 over 3 times 3 over 2. I can pre-reduce really nicely. Turn both of those into 1s. That into a 1 and this into a 5. So I end up having just 5 over 1 or just 5. All right. Last thing we're going to talk about is dividing. This one really is not that bad. Dividing fractions is really similar to multiplying them. You just have to do one extra step. Just like I hate subtracting, and I always turn it into adding, I hate dividing, and I always turn it into multiplying. To do this, we change the sign and flip. Last year, she used to call it KMF all the time. She even had you guys make posters and do stuff like that. And what I mean by this is that you change the sign from dividing into multiplying, and then flip the second fraction upside down. It's really, really similar to like the whole keep, change, or add a line and change the sign. Any little saying that you want to use to help yourself with that is good. She uses keep, change, or KMF if we're doing this with fractions like this. All right, so let's take a look at example 5. We got to keep, multiply, flip here. So I'm going to keep the 3/4. I'm going to multiply, and I'm going to flip that second one to 7 over 5, and then it just turns into rules that we had today. So they're both positive, so obviously my answer is positive. Look and see if you can pre-reduce. In this one you can't. So you end up getting 21 over 20, which again, you could turn into a mixed number. We're going to leave it there. And that's really it. So on the next page, I have you guys trying 1. Try this one last, pause it, and then unpause it when you're done, and then we just need to do some final thoughts. All right, hopefully that was enough time, so I'm going to make it 7 over 1. 7 over 1 is kept. You multiply, and then you flip that to 2 over 1. Can't pre-reduce, but you get 14 over 1, which is just 14. Nice job. All right, guys, so some final thoughts. When multiplying, you multiply the tops or the numerators and the denominators. Always check to see if you can pre-reduce before you multiply. Remember to reduce, see if you can divide both numbers in either one of the diagonals. To multiply mixed numbers, just turn the mixed number into an improper fraction. Any integer can be rewritten as a fraction with the denominator of 1. Dividing is the same as multiplying. After you, she would always call it KMF, so you know what, I might just say that. I was going to say change the sign and flip, but whatever you want to say. And that's it, guys. Thanks so much for watching.